Hello, I'm Paul Glazer. Today's session, Simio plus Python, Unlocking the Full Power of Your Digital Twin for What-If Analysis, is about more than adding a programming language. It's about extending what your models can do and where they fit in your organization. Simio has always been architected to integrate into complex, data-centric environments. That foundation matters, because what we're going to show today takes that capability to the next level. Python support isn't just a technical add-on, it's a strategic unlock. Simio plus Python will empower teams to modernize, automate, and scale their simulation-driven workflows. This will further move us from fit-for-purpose models to integrated, scalable digital twins that support dynamic, what-if decision-making. Before we dive in, quick introduction. I'm the Vice President of Consulting Services at Simio. I lead a team of engineers who help customers turn Simio models into scalable decision tools. I've been building simulation models for over 10 years, both as a consultant and as a business user. My background is in operations and supply chain, and I've worked across industries including chemical, automotive, and insurance. In those roles, I covered everything from engineering to strategic planning. A fun fact about me is that I began my journey as a Simio customer. I evaluated several platforms and chose Simio over some of the well-known competitors. Now let's talk about where simulation is headed and how we believe Python is going to play a key role in that evolution. Let's step back and look at the broader business context. Today's challenges aren't solved by a single tool. Modern business problems require a combination of analytical approaches working together. Simulation alone isn't enough anymore, not if we want to drive real value. That's why we believe discrete event simulation needs to be part of the broader decision-making ecosystem. When simulation connects with other technologies like automation tools, real-time data systems, and AI, it becomes far more powerful. Our goal is to position Simio not just as a modeling tool, but as a platform that integrates, scales, and enhances decision support across the business. Expanding simulation into areas like automation, data integration, and intelligent workflows is essential, and Python is the key to make that possible. This brings us to three powerful ways Simio and Python now integrate. First, we'll look at how the Simio Portal API and Python can work together. This allows us to automate runs, integrate AI machine learning pipelines, and support scalable intelligent workflows. Second, we'll explore how Python can help clean, transform, and prepare input data, bringing it directly into Simio from external systems. This replaces manual steps with repeatable, code-driven processes. And third, in many ways the most exciting, we'll show you how you can now embed Python scripts directly in Simio using new process logic steps. This opens the door for custom calculations, real-time API calls, and live integration with external tools. Let's start by first looking at how Simio Portal's API and Python fit into this picture. For those of you who aren't familiar with Simio Portal, it's our web-based application designed for operational modeling. It runs on a server either in the cloud or on-premise, and it's a bridge between simulation modelers and business users. With the latest updates, Simio Portal now includes a powerful and streamlined API. If you're familiar with REST APIs, then this will feel familiar too. If not, no worries, we've provided a Swagger page that will make it easy to explore and test API calls. This API gives you programmatic access to everything inside Simio Portal, your experiments, models, results, and more. It opens the door for real automation through external systems and seamless Python connectivity. Getting started is straightforward. You log into Simio Portal, grab your personal access token, and you'll use that to request a bearer token. Once authenticated, you can use that token to access the available API methods. Now let's talk about how you can use it. There are a couple of popular ways. The first one is the request Python package, which will allow you to interact with our API. You can send requests, retrieve data, launch runs, and more. We've also developed PySimio, which is a package that's wrapping the most common Simio API calls into a simple, easy-to-use format. You can use this to start runs, check the status, and retrieve output data, all with a few lines of Python code. Let's walk through a practical example of how planners can use Simio to make smarter, faster decisions. In many organizations, planners don't just want a single schedule. They want to see multiple options side by side to evaluate trade-offs. For example, a planner might want to ask for 3 different plans every morning. One that maximizes the service level, one that minimizes cost, and one that strikes a balance between the two. Once those plans are generated, they'll review the options and select one to publish and send to the factory floor. Now here's where Python and Simio Portal API come in. We can write a Python script that automatically generates all 3 plans every morning by interacting with the Simio Portal. The script launches each scenario, captures the outputs, and presents the results back to the planner without any manual inputs. But we don't have to stop there. Since we're already in Python, we can further automate the decision-making process. For example, we can analyze outputs from each plan and generate a recommendation, or we can extract key information such as a list of materials that could be expedited and pass that on directly to the scheduler. All this can be handled programmatically, giving planners both visibility and guidance, making the scheduling process smarter, faster, and more consistent. So from automation, let's pivot to AI and using Simio and machine learning optimization workflow. Simio's built-in experimentation tools work well for many use cases, but there are situations where you need more power and flexibility. That's where this workflow comes in. It starts with a modeler uploading a simulation model to Simio portal. Once it's there, we can access it through Python and connect to the machine learning libraries like Optuna for intelligent optimization. In this example, we have a model with a large number of input parameters. We expose those properties to the optimization engine, and Python drives the experiment, adjusting inputs, running simulations, collecting results, and iterating. One key advantage here is scalability. Because Simio portal is hosted on a server or a cloud-based virtual machine, it can be configured with a load balancer. That allows it to scale dynamically from tens to hundreds of processors running in parallel. This will make the trials run much more quickly and efficiently. And here's the best part with that scaling, it's elastic. Simio portal can scale up during the optimization process to maximize throughput, and then scale back down afterwards, which means you get high performance at minimal cost. This makes Simio portal an ideal platform for large data-driven optimizations without the infrastructure headaches. Now let's go inside Simio and think about embedding Python and a trained neural network directly into the model logic. Python can enhance Simio from the inside, especially when it comes to machine learning. Last year we introduced a neural network element in Simio. It includes a built-in trainer, which is great for smaller use cases. But as many of you know, training neural networks at scale often requires large data sets and specialized compute. That's where Python and NVIDIA GPUs can come in. Let's say you have a large volume of historical process data. You can bring that data into Python with a data frame and use a library like TensorFlow to train the model externally. Once trained, you can export that model in an ONNX format, an open standard for machine learning models, and then import that ONNX model into Simio. Now Simio can use the neural network during simulation to predict processing times dynamically, based on real-world patterns, trends, or conditions that are reflected in your training data. This approach combines the flexibility and compute power of Python with the real-time decision-making engine of Simio, giving you more intelligent, adaptive simulations. Another AI-related use case is the natural language prompts. What if users could ask a model questions directly? Let's explore how Simio can do that next. What if you could simply talk to Simio? With a combination of Simio, Python, and an MCP server, we can now integrate Simio with large language models like Gemini or ChatGPT to create a natural language interface for simulations. Here's how it could work. A business user could ask a plain language question like, what happens to average delivery time if I reduce my shift length by 2 hours? The large language model interprets the prompt and translates it into a set of simulation variables. Those variables are passed through Python to the MCP server, which executes the plan in Simio, gathers the resulting data, and returns an answer clearly and conversationally. For example, average delivery time will worsen by approximately 1 day per order. Would you like to know why? This is more than just Q&A. It's a system where users can ask operational questions, run simulations behind the scenes, and get back actionable, human-readable insights. It's a powerful blend of large language models, automation, and simulation, and another way that Python unlocks an entirely new mode of interaction with Simio. Now that we've talked about Python and Simio together, let's talk about using Python inside of Simio. The first key use case here for Python inside of Simio is automating data preparation, specifically cleaning, transforming, and validating input data. With Python integration, you can now run a script during data import. That means when you click the import button in Simio, a Python process can connect to external data sources, transform that data into a structure that the Simio model needs, and validate it, checking for errors, missing values, or inconsistency. All of that happens inside of Simio, without the need to manually adjust spreadsheets or run external pre-processing steps. Even better, you can use trusted libraries like Pandas or NumPy, which are built for exactly this kind of work. This gives you full control and flexibility over how your data is handled. No more reformatting Excel files or building fragile workarounds. This functionality lays the groundwork for repeatable, end-to-end data pipelines, allowing your simulation workflows to scale cleanly and efficiently without relying on middleware or manual intervention. It's a big step towards full automation in how models consume and prepare real-world data. Now let's apply this mindset to a real challenge, connecting to complex enterprise data sources. If you're working in a large enterprise environment, chances are you have an ERP system like SAP, and you know how difficult it can be to access that data. Traditionally, it takes time, coordination, and often middleware to get data from SAP in a simulation-ready format. But now with Python available in Simio's data importers, that process becomes much easier. Using a Python package like pyrfc_read, you can provide your SAP credentials, connection details, and now you can query tables directly from SAP. You can filter and transform that data before it even enters Simio, and import exactly what you need: clean, structured, ready for simulation data. This eliminates the manual prep work and brittle pipelines that often sit between simulation and source systems. You no longer have to export that data manually, run it through Excel, or build an external integration. While Python's doing the heavy lifting behind the scenes, you can now bring real-time production-grade ERP data directly into Simio, faster, cleaner, and ready for use. So now that you can connect to a data source, let's explore the full end-to-end workflow could look like with Simio and Python. In this example, we're going to show how Python and Simio can work together to automate simulation, data handling, and visualization. We'll go from left to right. An analyst receives a request. For example, what would the impact be of adding a new piece of equipment at a manufacturing site? The analyst uploads a small file with manual inputs, maybe some assumptions or configuration values, into a shared cloud storage layer. That same data environment is already getting automated updates from ERP, MES, and other systems. All of that data lives in one place now. A Python script detects this new file, validates the input, and kicks off a Simio portal run automatically. Inside Simio portal, the model executes, and a Python script inside the model can now import external data sources, transform them as needed, and run the simulation. On the output side, we run another Python script that formats and structures the results for visualization layers. This could be Power BI, Tableau, or another custom dashboard. Once complete, the system notifies the analyst by email that the data is ready. The analyst logs in, grabs updated visualizations, and prepares a summary to share the results with the business. What's powerful here is that analyst never had to touch Simio desktop or even interact with Simio portal. They just submitted a request, and everything from data preparation to simulation to visualization was automated behind the scenes, powered by Python and Simio. This is exactly the kind of streamlined, scalable decision support system we can enable now with Python. Now let's talk about the last and most exciting part, the ability to run Python scripts as process logic steps in Simio. Starting with version 19, you'll be able to call custom Python code directly within your process logic, a feature we're really excited to introduce. Let me walk you through what that looks like. On the right-hand side of the screen, you'll see a new scripted steps section under the Definitions tab. From there, you can create new scripted steps, just like any other step in Simio. In this case, we're creating one called Choose Server. Each scripted step can have a custom property or custom properties. These are the values you want to pass from your Simio model into the Python script. For example, these could be state values, entity references, or model properties. When you double-click the scripted step, Simio will launch your local IDE, whether that's VS Code, PyCharm, or another editor, and you'll be able to create or paste your Python code in. You can import packages, write logic, connect to APIs, or perform calculations, whatever your use case requires. Once you've saved the script, the Python logic becomes a reusable step. You can drop this directly into your process logic just like any other Simio element. We expect this to open up immediate opportunities for custom calculations that are hard to do in Simio, API integrations for external systems, or anything else where Python gives you more power and flexibility. Let's start with a simple use case: data calculation. One of the things Python does exceptionally well is data-driven calculations, and you can now bring that capability directly into your Simio models. With just a few inputs from your simulation, like those states or property values or timestamps, you can call a Python step to perform real-time forecasting, run curve fitting, or dynamically estimate process times. It's fast, flexible, and completely embedded within your process logic. This gives you powerful alternatives to the traditional Simio expressions, especially for complex or nonlinear logic that would be difficult to manage natively in Simio. And there's another major advantage here. You no longer need to embed large reference tables inside your model. Instead, your Python script can act like a smart calculator, receive a couple of values, look up or compute an answer externally, and return that result to Simio almost instantly. This approach reduces model size, increases maintainability, and taps into the full power of Python's analytical libraries, all from within your simulation logic. Now let's look at how Python can link Simio to real external controllers. Another powerful use case for Python and Simio is linking your simulation directly to real-time control systems. Let's say you're working on a warehouse automation project and considering the addition of AMRs. If you've done this before, you know that one of the first steps you have to do is build logic in Simio to simulate fleet management, deciding which AMR gets assigned, when, and how. Traditionally, this means recreating the control logic manually inside of Simio. But now with Simio Python steps, you can do something much more realistic and scalable. You can call the actual AMR Fleet Manager's API directly from Simio. Imagine this: the robotics provider gives you an API access to their live control system. They tell you what data they need, for instance, zone, order count, load size, whatever it is, and you configure a Python step to send that data during the simulation. The Fleet Manager then returns a response, maybe which AMR to use, its ETA, or how to prioritize traffic, and Simio uses that output in real time without needing to duplicate the logic. This means your digital twin is now interacting with the exact same controller logic that runs the physical system. That improves both the speed of development and the accuracy of your simulation. It also opens up new opportunities for testing, validation, and pre-deployment evaluation, all using the real system logic in a safe simulated environment. Exciting stuff, right? Now let's talk about when and how these features are going to be made available. First, the Simio Portal API and Python and PySimio Python packages are available today. If you're using Portal, you already have access to the API, and you can download the PySimio package from our GitHub repo and start building these scripts immediately. In the initial release of version 19, we're going to introduce the Python step feature, the one we walked through today. This will allow you to run Python scripts directly inside your process logic. Later this summer, we'll expand the Python support further to include data importers and exporters, and we'll create additional SimBits and training for you to learn from. Now that we've introduced these capabilities, let's talk about who stands to benefit most from our Python integrations in Simio. First up is modelers. Modelers are going to see immediate gains through faster development cycles, more automation options, and greater flexibility in their process logic. With Python, you can handle complex calculations, access external systems, and reduce the need for workaround logic inside the model itself. Second, data scientists and analysts. Python's going to open the door for these data professionals to connect with simulations like never before. They're going to be able to integrate Simio into machine learning pipelines, run simulations through APIs, and feed real-time data and consume the results dynamically. They'll also have the ability to automate planning and analysis workflows without ever touching the desktop interface. Business users may not be writing code, but they're going to benefit the most. They're going to get more intelligent decision support. They're going to have access to optimized schedules, automated reporting, and a broader range of what-if options to explore without needing a modeler on standby. And finally, our IT and engineering teams are going to benefit as well. Python and REST APIs allow Simio to fit more naturally into enterprise architecture. It allows easier integrations with data pipelines, cleaner authentication and security models, and better alignment with existing cloud analytics and data strategies. This isn't just about scripting, it's about making Simio a more scalable, integrated platform that fits seamlessly into the digital ecosystem. To take full advantage of everything we've discussed today, there are a few core skills that will be essential, especially as simulation becomes more integrated, automated, and intelligent. First, Simio modeling skills. You'll need a strong foundation in Simio itself. Understanding the object-based modeling framework as a start, being comfortable with the process logic, data tables, and simulation structure as well, and knowing how to represent a real-world system accurately inside of Simio. This is the modeling layer, and everything else builds upon that. Second, you'll need Python programming. You'll need to be able to write and debug Python scripts. You need to understand how to work with libraries like Request, PySimio, Optuna. You need to be familiar with passing data in and out of Python scripts. And you'll need to learn how to debug in your local IDE. You don't need to be a data scientist, but you should be comfortable with scripting, packages, and troubleshooting. And finally, you'll need API knowledge. A working knowledge of APIs will be key here. On the Simio desktop side, you'll use the API to access tables, states, and controls at runtime. On the Simio portal side, the REST API is going to be how you automate workflows, integrate with machine learning pipelines, and interact with models programmatically. Understanding these interfaces is what enables Simio to function as part of a larger decision-making ecosystem. So let's take a step back and look at the broader opportunity here and how all of this is going to reshape simulation moving forward. I want to challenge you to think bigger. Think of Simio not just as a simulation tool, but as a what-if platform, one that supports a wide range of use cases, all built on a single digital twin. By combining your model with historical or real-time data and the flexibility of Python-powered workflows, you can now unlock entirely new possibilities: simulation, optimization, scheduling, and emulation, all from the same model. Embedded AI and machine learning, automated workflows, and intelligent feedback loops. Real-time interactions with other systems, users, or even AI agents. This is about transforming simulation from a specialized tool into a shared platform for enterprise decision support. That's where Simio is headed, and we're excited to take that journey with you. Thanks for your time today, and as always, don't hesitate to reach out to the Simio team with questions or ideas.
Good morning. How are you, Paul?
Good. How's it going, Jeff?
It's going well. We have a few questions about your presentation and about the Python integration. The first one has to do with something you mentioned about integrating Python into evaluating what-if schedules. And the question is, what exactly does the Python do? Are you selecting from a set of predefined inputs on a list, or are you actually doing some kind of computation and then feeding that into the portal?
Yeah, so I think there's a lot of cool options here, right? So I think the simplest that I've seen out there is you could have different dispatching rules. So if you have a scheduling system and you've got everything set up, maybe you've configured 2 or 3 different sets of dispatching rules. You can pass that in your Python script as a parameter into your Simio run, and that way you'll just run a different set of rules. I think you can get more complicated from there. I think you can create different data sets, or you can potentially even reorder those your orders in a different sequence. So if you want to see things differently, so Python just opens up a lot of options. But yeah, I think you're going to have to do some customization on the Python and the Simio side to get what you want there.
So it sounds like you can basically manipulate any of the controls that you can normally do on a Simio experiment from within the Python. So if you set up the Simio experiment to handle any level of controls like dispatching rules or sequencing or data tables, you can manipulate that through the Python so that you can then feed that in based on whatever the selection goal, whatever the optimization goals are.
Yep, that's it exactly.
Perfect. That sounds good. Can we have the next question? So this question has to do with using Python for route optimization. Can we use Simio plus Python for route optimization, such as how many vehicles I need for picking up entities from several locations within time and capacity limits, and what should be their path to minimize distance? So it sounds like it ties in a little bit with what we saw in the SeaGrid presentation.
Yeah, so I think there's kind of two interesting things here, Jeff, and I know we've talked about this one a little bit, so I might bounce part of this back to you. I think you could use kind of that machine learning example that I provided, where you could surface maybe some different properties, and again, you could do some different dispatching rules or some properties that are tied into something that's important about that AMR system, and then you could let an optimization solve that problem. And maybe you're going to do something like a service level threshold, or number of counts, or whatever that is, and I think you could do an ML loop there. I think it would be an interesting one, and maybe you can speak to this, Jeff. I wonder what you could do inside of Simio. So now that we have the Python step and you're able to surface information to some type of Python optimizer, maybe that's a case we could use as well.
Yeah, I think that is the case because of the way that the Python integration happens within the Simio model. It's used as a process step, so you can execute the Python code and then go off and do any kind of optimization that you want. Come back to Simio and then do some additional work on data tables or route selection or things like that, and then you could um, optionally go back to a different Python step, so they can have that two-way interaction because of the information flow in both directions, from the Simio model to the Python, and then back from the Python step to the Simio model. Perfect. Next. So this natural language, I think we got some interest in that. You talk about, I want to talk into my computer like you see on TV and have it tell me what to do, and that sounds really good. I'm going to eventually get to the point where I can say, "Hey, build my Simio model," and now use that model to optimize. And so the question is, at this point, is this conceptual, or do we have actual running models where you've used this automated translation and of voice into Simio?
Yeah, so at the current moment, it's conceptual. I think what's really interesting about the AI and the natural language side of AI is this ability to take something that a user says and turn it into a prompt. And now that you have the Simio Portal API and these Python packages, I think it's going to be very quickly that either we internally or we start to see users get to these use cases where you define a series of functions and you help the AI understand through something like an MCP server what is capable on this little Python script that you write. So maybe it's you write a handful of functions like get a list of models, how to run a model, a couple of things like that. And I think early on we'll see these are going to be pretty tailored to specific use cases, but at the speed at which at least the packages I work with pick up and understand context, I don't think it'll be too long before business users are really able to interact with simulation. And I think that's for me the most interesting part, right? Is those are the people that are going to derive the value out of simulation. Having them interact more closely with it is going to make it more powerful.
Yeah, I think this Python integration is going to really help in that respect, because as you mentioned, these packages are evolving really quickly. And so because we will be able to tap into those at basically no additional cost without going into your Simio code to manipulate it, you'll be able to use those packages. And so as the language recognition becomes better, and it's just going to be simply a matter of mapping language terms to Simio terms, and that mapping should hopefully be pretty straightforward. So we're definitely looking forward to that. I want to be able to open up my phone and say, "Go run this model on Portal and report back to me as what's happening." So we'll
Yeah.
look for that.
And I think the other thing, Jeff, is one of the things I like about Python is it's really a quick way to get to POCs and figure out if things work, right? So I don't know that that's going to be the end, language that all this stuff gets put into and gets productionized for our customers, but the ability to show people what's possible, I'm excited about Python's speed and what it brings there.
Yep. Next question. Can you reference an entire data table from Python script embedded in process logic? So, like, I'm assuming there are two parts to this question. You have the data table on the Python side, whether it's in Pandas or some other structured format, and then you have the data table on the Simio side, which could be a data table or an output table, and they want to understand the connections between those.
Yeah, I think the quick answer here is yes. So if you think about running that script inside of Simio now, so that Python step, there is a Simio desktop API, and that's really how you're going to interact and load that data into the Python side. So you're going to call that table in your Python script, and then you can manipulate it and do your calculations, whatever you need to do. And then you can provide data back either in the form of tables or states or anything like that. So Jeff, I know you're a little closer to this question than I am. Don't know if you had anything to add on there.
Yeah, just mechanically, we've been putting in some work to simplify that process. And so, as Paul said, the short answer is yes, you can do that conversion. And what we are trying to finalize before the release of in 19 is making that as easy as possible, so that rather than going through any kind of complex API calls, we can simplify that. And that again is where Python really is strong for us to be able to create helper functions and things like that, so that you don't have to focus on exactly what's going on behind the scenes on that connection between the Simio internal data and the Python script, and that we automate as much of that as possible. So I think there are going to be some very, very good developments in that in the near term. Okay, you mentioned using a company's API for AMR usage. Does that mean we can call that API to run the logic for the model rather than building the logic yourself manually?
Yes. Again, I think the short answer here is yes. I'm excited to see this use case in particular. It's one we've talked with customers and consultants about. The situation here for those maybe you have worked as closely with AMRs and fleet managers. Typically, this is a piece of software that the vendors own or somebody's created, right? That has complex algorithms and lots of knowledge and their secret sauce in it. And we see the Python step as being able to surface the same information from the digital twin to that application and then get the answer back. So, as I alluded to in the example here, maybe it's traffic, whatever variables you need to pass in, that could be a table, a few values. You surface all that through an API call, which you can use the request package in Python, send it over to that application and get an answer back. So, I think this is going to be super cool, especially in those situations. So you don't have to recode all that and you're going to get a closer answer.
Yeah, an interesting aspect of this is when you're using an API, say for an AMR company, you're have an AMR supplier, and they won't tell you what their logic is, but they'll give you the API to actually get the information back. So you don't know the logic. So you wouldn't have the option to code that in Simio yourself, but now you would have the option to simulate the system that you would have if you use that supplier's AMR. So I think that's going to be a really interesting use case going forward. So this question has to do with using external packages. So in the slide, you mentioned importing pandas and PyRFC read. Those are both, if I remember this correctly, both of those are open source. And so question is, are there any limitations to the external packages you can use? So for example, if I want to use Gurobi or Cplex for optimization, are there limitations on what I can do there?
Again, I think the short answer here is no. There's not going to be a limitation. Just to kind of expand on how this integration works. So you're going to have the Python script, which is going to live inside of Simio, and we'll just for this case assume that you're writing a scripted step. So the script itself is going to live inside the Simio file. That's where that information will be contained. And then either on your desktop or the server, wherever that's located, you're going to have your Python directory, and then those packages will be installed there. So as long as you have the rights and the licenses, everything lined up, there's no limitations here on packages. It's going to work just the way Python works on your machine with other pieces of software and IDEs.
And so you mentioned that the Python scripts themselves will live within the Simio model and the packages will be external. Can you elaborate a little bit on how will Simio use Python? So will Simio ship with Python? Will it use my Python on my computer? Do I manage my environment? How is that going to work?
Yeah, so Python will not ship with Simio, so it'll be something you'll have to install separately. But you'll locate that in the settings, and you'll indicate where the Python directory is, as well as what IDE you like to use, and then Simio will reference those. So the script will stay, but the Python engine and those things will be separate.
And so speaking of the IDE that you want to use, does that extend to debugging? Will I be able to do like live debugging with my Simio model running through the IDE?
Correct. Yes, that'll be possible. I think at this point we've tested VS Code, but I think we want to extend that same support for other common IDEs. But yes, you'll be able to see that.
Yeah, I think that's also going to be a game changer with this Python integration because as you use it to develop these complex algorithms that you talked about, doing forecasting or curve fitting or things like that, it's going to be invaluable to be able to take a look at that inside a debugger as you're running the model. And since we can get the data from Simio directly into the Python model, into the Python script, we'll be able to see what Simio sees also inside the debugger by passing that information. So I think that's going to add a lot of functionality to be able to debug and verify some of the complex code that we're including.
Yep.
For Python integration, this was what we just asked. I think we just covered this one. It's the question about built-in Python versus using your package. I will say, I will make a comment about that we've evaluated different alternatives there. And so in our initial release, this is the direction we're going. But we are going to continue to evaluate that decision as we go. I think it makes it a lot easier when we use your environment, that you control those imported packages, and you can decide versions that you're using. And with the commercial code, then that's going to allow you to manage those commercial licenses, so that we don't have to do that.
Yep.
And so this next question for complex data connection, the one you talked about, yeah, this is exactly what we just said also. So the question is, will the Python code be stored in the Simio model, a project file, or will it be separate? And how will the user interact with the code? So since we've already covered that, let me just make a comment here, and then you can chime in, Paul. So you will work with your IDE, and when you place a Python step, the IDE will open with a template, and then you will add the Python code there, and then when you save that, it will be saved to the SPFX, or the Simio project file, and so that part of it will live within the SPFX file. And when you either give that model to someone else, or you reopen the model at some point in the future, that model Python code will be extracted, and then you will have access through the IDE also.
Yeah, I don't know how much to add there. I think I like the idea that you can move that script around, right? So as you think about the model development process and trying to keep things up to date, having that integrated with Simio is going to be a really nice feature.
Yeah, I agree with that. How far can we go with the Python blocks in Simio? Will it be possible to export output tables during the simulation using Python, for example, and create special reports in special data formats?
Yeah, so I'll probably expand on this one a little bit and go both output and input side here. So, if you think about the input side, you can get data from different data sources, do your transformations, your validations. And again, that's going to be on like a data connector. So if you think about where in Simio that's going to be. And then within Simio as well, you're going to have these steps, which you could absolutely do something like this. So let's say you want to run a process at run ending, and you want to take a series of tables that are inside of Simio, and you want to transform them in some way using Python. You can absolutely do that. You can send those to blob storage. You could put them into a database, whatever your workflow needs. You're now going to have that flexibility here. So, yeah, definitely possible.
Yeah, and I think our users who rely on dashboards and want to have those kind of graphics and business charts and so on are going to find that particularly useful. That you would be able to do all of the data manipulation post run inside using Python code, and then export that either to a database or somewhere else that you could be used later. And you could also have a use case where you export data from one run and then import that data into a subsequent run. So one run can talk to another run in terms of that kind of um, um, uh, results export and so on.
Yep.
Um, Debugging, we have covered. Basically, the question is, will I be able to use my IDE debugger to do live debugging? If so, how will that work? And the plan is to support multiple IDE debuggers. As Paul points out, at this point in development, we primarily use VS Code, but fully expect to be able to use additional IDEs by the time we release. So you talked about neural networks, and I know neural networks were introduced a couple of years ago. We've actually had a couple of Simio Sync talks when they were first introduced, and then maybe last year on applications. Can you give an example of where you could use one of these models and describe how this works inside Simio?
Yeah, so I think really kind of two use cases come to mind for me. The first one is forecasting a lead time, and for both of these examples, I think about data that you may have in your enterprise system, something you can reference and train these neural networks on. So lead time is the first one that comes to mind. So if you have, let's say you have a facility and you know um, when orders were produced. So given a certain order release time, when that order was produced, you can build a model around that. Now there's a lot of questions and a lot of work to do around what inputs do you want to pass in to calculate that time, right? Is it weather specific? Is it month specific? All those things. But then you could forecast a value. And so you could rapidly create a supply chain model, right? That kind of black boxes your facilities and gives you an idea what that flow is going to be. On a tighter level, if you were to go inside the four walls of that factory, I think an exciting use case is if you have MES data, and let's say maybe it's chemical related and there are a couple different processing parameters, you could train a neural network to give you the processing rates. And so that way, depending on different usage of equipment or temperatures or whatever that is, you can get a more accurate processing rate than you could off of just a static number. So I think, kind of think forecasting values and think about where you have lots of enterprise data that you can train that network on. And I think those are going to be the early applications.
Yeah, I agree with that. And that one of the applications that we have seen relates to the lead time prediction, where we have historically used look-ahead simulation. So you could start your model from a given state, run the model for a while, and then calculate those lead times. And what the neural network is going to let you do is use that model to train the neural network. So use a model that will identify or that will calculate lead times based on current state, use that to train the neural network. So then in your operational model, you don't have to do the look ahead simulation. You just plop in the neural network at the point where you would have done the look ahead simulation. I think that's the biggest use that I've seen. And then separately, there's, you can use other people's neural networks. So if you have one that's already done using, you can import that in Onyx format, and then use that in your model for any decision-making context. If a Python step takes several seconds or minutes to run, does the Simio wait for it to complete execution?
Yes, that's my understanding here. So it's gonna look at that step and it's going to execute it and wait for that response to come back. I do think this is going to be something interesting as we get more into Python and reaching out to other applications, is making sure that our profiler and our other tools are helping you understand when and where the time is being spent, right? So if you're reaching out to this call a lot of times, or the call takes a long time to complete, you can see some delays in the simulation. So helping modelers understand the time that it will take will be important. But yes, we will wait for that step to complete and then move forward through time.
Okay, yep. So far, it was possible to develop steps and add-ons in C Sharp. So is Python just an easier programming method within Simio?
Yeah, I don't know. It's necessarily easier. I think this kind of depends on your background and where you're coming from. There's definitely on our development team, they would jump to C sharp in a heartbeat. I think Python is interesting to me, just from the educational side. And Jeff, I think you can speak to this as well. There's a lot of classwork, a lot of training. It's a language that's out there and people are familiar with. I also think tools like ChatGPT, Gemini, things like that are educating a base of people in programming with the start in Python. So, I don't know it's necessarily easier. I think it's an alternative method. And I think for me, it's about the packages, right? So I know there's similar concepts in other languages, but lots of mathematical calculation based packages you can learn quickly, they're well supported, and you can bring into your code.
Yeah, I think that I agree with that the external packages really help. In terms of the programming, yeah, I mean, it depends on what you know. If you know Python, Python's clearly going to be easier. If you know C Sharp, then C Sharp might be easier from a programming standpoint, because both of these tools would use our API. So your interaction with the Simio model is going to be the same at the conceptual level. It's just a matter of whether you implement that in Python or C Sharp. Another difference here is when you do C sharp add-ins and steps, you compile to a DLL, and that DLL has to be available for use. And so if you wanted to share the model with someone, you would obviously have to share that DLL, versus the Python, which the actual Python code is going to be embedded in the model. And so it's interpreted, it's running in an interpreted environment as the model goes. I can definitely see use cases where a project would start out using a Python interface and Python development, and then transition to C sharp, so that you can get that execution speed if there is execution speed benefits there. And you could also Because you develop it in C# and it's shipped as a DLL, they don't have access. Whoever you're sharing it with would not have access to the source code, whereas with the Python step, they would. And so I think you're going to see use cases where you go back and forth between those two, and each one is going to have each one is going to have its place. But I do think that the Python step is going to broaden the the base of users that are able to use a programmatic interface to interact with their Simio models.
Yep, I agree. I think Jeff, on that note, if I was to give people two places, I'd pick Python over C#. Right, it's going to be on that calculation side, and just if you've experienced this in Simio, sometimes if you have tables and you just need to iterate through them and add on data, I think Python's going to be a couple lines of code versus maybe a little bit more of a struggle in Simio. And then the second is these applications where we can reach out to an API. So you just use a request package, you can get that set up quickly and get that data back and forth. So those are kind of the top two for me right now.
Yeah, and I would just add to that a third one where I want to reach out to a database and grab 5 tables and then do a complex join, and then do some kind of querying from that join in Python. That's quite simple to do. And then in the second phase of our Python integration, when we introduce Python elements in addition to Python steps, you will have persistent storage where if you did go away and pull those 5 tables and develop your complex join in a Simio step, we could then store that information inside the Simio element so that future invocations of the Python would have access to that directly. So I think that complex data manipulation is the third use case where we're going to see a lot of use in Python.
Yep.
Okay, this will be a good one, Paul. What's the advantage of using Simio as opposed to simulating in Python itself? So if I'm going to code stuff in Python, why not just use Python?
Yeah, that's a good question. I think obviously there's use cases for simulation in Python. For me, they're probably on the simpler side. If I had to give you my number one reason, it's going to be speed to value, right? You're able to come in quickly, be data driven, and build a model in Simio. In Python, you're going to have to code a lot of that yourself. I know there are some packages out there, but really for us, this is about bridging the gap, right? Wherever those tools exist in Python and we can use them and get speed and value for our customers, let's do that. Let's not reinvent the wheel. But we think the two together is going to add a lot more value.
Yeah, that I would totally agree with that. You could develop it completely in Python, but that's definitely going to be slower from a development standpoint, and you're going to redevelop things over and over. So I think adding this capability to do this type of scripting in Simio is going to give you the best of both worlds. It's definitely going to expand the flexibility, be able to code custom logic and things like that without having to do the baseline coding where you're just developing an event calendar and things like that, and then statistics tracking and the things that happen behind the scenes. More questions? Is there a release date for Simio 19?
Well,
I'll let you take that one.
I was going to say, since I'm not the person releasing it, I don't have an exact date, but I can put a range on it of June, July. I'd probably look somewhere in the middle of that range.
Okay, that looks like that is all of our questions, Paul. Thanks for putting this together. I think this gives a very good overview of our Python integration. I know we have another talk in tomorrow's session where you're going to go into a little more detail on this. So if anyone out there is interested in the Python integration in particular, I would encourage you to attend that session tomorrow also.
Very good. Thanks, Jeff. Appreciate all your good questions.